Thank you, Theodora. Hi, everyone. So this is a demo session called Simplify App Dev with Cloud Native PostgreSQL in Azure HorizonDB. So welcome, everyone. So today we'll talk about AI features of Azure HorizonDB. If you missed an announcement by Satya yesterday, let me give you a quick refresher. So HorizonDB is our new PostgreSQL database, and just yesterday we announced public preview of it, which we are very excited about. So what we did, we took open source PostgreSQL engine and connected it to a cloud-optimized, scalable storage backend. And that allowed us to achieve higher resiliency, larger scale, and better performance for Postgres workloads. So with HorizonDB, you'll find 3 times higher throughput on transactions and 3 times faster vector search. You can also scale it to a very large databases, enable up to 15 read-only replicas. So it gives you a very scalable, powerful engine. And on top of that engine as well, we've built AI features. So HorizonDB is designed for this new era of AI agents. So it comes with built-in AI models, AI pipelines, and AI functions. And this is what we are going to focus on today. And we'll test this claim of having AI functions and AI features that simplify development of apps by building this agent today on the stage using HorizonDB features. So let's start from this demo application. So this is the end state. This is the app that we are going to build today, or at least some key components of it. So what you see here is a Java Room Designer app that helps me design my room. What we have here is a photo of my Brooklyn loft with the first piece of furniture that I have, this gorgeous couch. And I'll use this app to help me pick other furniture that fits this style and color palette of this room. So all I need to do is click Design My Room, and this app that we are going to build together, it's going to analyze the photo, determine the style and color palette, right? And scan the product catalog and pick the furniture that actually fits into my room, right? And voila, the room is furnished. So no more kind of this very difficult choices, which piece of furniture to put, right? Everything is done for me. And under the nice small budget. So fantastic. So you can see here all of the pieces of furniture selected, right? So on the surface, this may seem a little bit intimidating or a little bit sophisticated, right? It seems like a complex app. But this cannot be farther from the truth. This app actually is intentionally designed to be very simple, and we'll show it by building components of this app one by one to show you how this app was actually built and how we simplify development process with HorizonDB. So the first step in our journey would be connecting models, right? So if you want our agent to be able to reason, right, the first step always is provisioning models, connecting them, all of this infrastructure setup. With HorizonDB, that's the first step that we get to skip. So instead of doing that, I'll just show you how you provision HorizonDB. And as part of that process, we'll actually bundle models into the database. So the database comes already with all of the model connections provisioned. So what I'm going to do, I'm going to click this button. And throughout this demo, I'll actually use this Postgres extension for VS Code. So this is our product. All of the experiences that you will see is actually based on that. I highly recommend you use it for your Postgres work. And in this new server screen, we have a new entry, Provision HorizonDB, right? So I'll click it. I'll log into my Azure portal using my credentials. And then I'll specify details of my cluster, right? So I'll name it my HorizonDB2. I'll provision a little bit more compute cores. I'll select my user. And this is where I can bundle my AI models and AI-related features here. Just a simple checkbox, which activates model management and pgvector and DiskNN vector search extensions for Postgres, right? So just like that, I'm ready to provision my Horizon DB with all of the AI enablement kind of models already provisioned together with it. So we won't wait for this process to complete. For this demo, we'll use, and it will run in the background, but and I just almost clicked it just in time. Something didn't go as well. But I have my pre-provisioned Horizon DB for the demo ready, so we can just jump right into this one, right? So the first step, or the next step in our app development journey, right? So now we have Horizon DB with AI models enabled. So second, let's prepare data, right, from our product catalog for AI consumption. So for this, let's first take a look at the data that we have. So here is a product sample table. You can see it has all of the kind of product catalog related details here, right? But what it doesn't have embeddings, right? And embeddings are important for our model, for our app, to be able to reason which pieces of furniture semantically kind of fit into the style, right, of the room. So we need embeddings almost always when we build AI agents, right? So let's add embeddings to this table. Actually, we'll do a little bit more sophisticated than that. So what I do have, though, in the database, as I mentioned, we have pre-provisioned the models, right? And in SQL, I can actually inspect the model registry and see what kind of models I have here, right? So now you can see 3 managed models were provisioned automatically with the database. I have a generic chat completion model here. I have text embedding model, right? And I also have a very powerful model, which is semantic re-ranker model that we'll use later, that allows us to improve quality of search results. We also support, if you have your own enterprise models, right, we also support bring your own model feature where you can connect your existing models to the database as well. Okay, so now we have the models. And the next step, we'll create this AI pipeline that takes our product catalog data, right, and generates embeddings for them, and all in the database, right? So this is a full definition of the AI pipeline. So we say, hey, from this product sample table as a source, perform these steps. And this is a simple sequence of steps, right? First, we'll chunk the data, which is important for accuracy of our vector search later, right? So we need to split it into little pieces. So this is a chunk function. And then we are going to, for each chunk, we are going to generate embedding, right? So this is how I specify that step. And that trigger is important element here as well. This pipeline not only will process my existing data and product sample table, but it also connect a trigger to it. So any changes in my product catalog will automatically go through this pipeline. So it'll incrementally keep updating the data and generate new embeddings. So let's run it. Okay, pipeline created successfully. I can see the status of my pipeline using SQL as well. So here is the status. And if you look here at these total processed items, if I keep running this status query, you'll see it's increasing, or at least it should increase. Or maybe not. Okay, let's pretend that it's increasing. If not, it will be interesting to see what's happening. But in addition to the SQL status of the pipeline, I can also use UIs that we've developed for this in this extension. And I can look at the pipeline status here. So I can just open the pipeline window. And see visual representation. So that's a backup embedding. Let's see, this is green still, okay. And this is our new embedding pipeline that we've just created. And here's a kind of a diagram of everything that is happening. Okay, so you can see that we have, so let's close this one, extend this a little bit. You can see what's going on here, right? So we have our source table, which has 60 rows, right? So this is all of the rows that we have here. Then chunking process splits each row into a few or more chunks, right? And it generates 116 chunks. And then embedding step talks to the Microsoft Foundry model, embedding model that we pre-provisioned with the database, right? And generates 116 vectors, right? So all of that is pretty good. So if you look at the output of this final sync step, right, we can see the table here. The output table is embedding pipeline output, right? So let's see what that table has if our pipeline succeeded. So this is our pipeline, output of the pipeline table. So let's see how many rows. Yeah, so it actually did succeed. So our status now, if you run it again, shows 116 rows processed. So it was just a little delay in our demo. That is awesome. And now we can see the output of this embedding pipeline, right, table. So here you can see the chunks that were generated, and more importantly, the embeddings, right? So now we have our product catalog fully vectorized, so it's ready for our vector search to find relevant items. So let's do just that and demonstrate a very simple query, a little bit bigger, that performs vector search. So if you're not familiar in Postgres, this is a vector search operator, right? So we are performing vector search across our output table and trying to find best chair that is comfortable, right? And this is the results. Okay. So some chairs were returned, so that's great. But what if we want to change the data, right? So let's add a new item into our product catalog, product sample table. So we'll just insert this new row. And very quickly, if you look at the count of the rows in the embedding pipeline, we see that it's already 117, right? So the pipeline was watching in the background and asynchronously without blocking my actual insert, right? Because we want to keep our database responsive. All of the inserts happen very quickly, and pipeline asynchronously back processes all of the new data. So it did process that very quickly, and now in our output table, we have 117 items. So now if you repeat that vector search, you can see that the newly added item is already in the results of the vector search, right? So that gives you a very simple way to build this vector generation pipeline without any kind of steps, covering all of this complicated use cases like incremental updates, all of that. So all of this complexity is taken away. Great. So how are you doing on time? You're doing great. So that's first step, right? So we prepared our data. Now we can start searching over it. And we'll search in a very scalable manner and in a very sophisticated manner as well. So let's do a retrieval step. So in order to enable retrieval of data, right, from our now vectorized product catalog, what we want to do, we want to achieve high accuracy of the results, and we want to make the search very fast, right? So in order to achieve both, we'll enable two types of searches. So we'll do hybrid search. So first, we'll enable full text search extension on our database, and we'll create full text search index on our product catalog. So this is the new PGFTS extension that we've enabled on HorizonDB, which basically brings a Lucene type functionality to Postgres. So now in Postgres, we can do full text search. That's awesome. And we also provision here our DSKNN vector index that gives us better performance compared to PGVector, right? So it's a very fast vector search. So now we have created these indexes, we can perform vector search. And to simplify it even further, we created this simple function that allows you to perform pretty sophisticated operations with just this very simple syntax, right? So what we are searching here is this string that kind of describes the style of the photo that we saw, right? So you can see here we, in the prior step in the app, from the photo, we kind of deduced the description of the room, right? So we are skipping that for the sake of this, for the sake of time. But this is the output of that step. So now we have textual description of the room, right? So how to describe the style. Then we specify the source table where we are going to search, right? The column and an important parameter, a type of search. So now we are specifying hybrid search. We can do vector search. We can do full text search. But hybrid combines both. So it kind of gives you strengths of both. So we are doing hybrid search here. And then just join some details so we have a nice output. So let's run this. And here you can see the results, right? So some results were returned. And interesting part of this about these results is the influence that hybrid search brings into our search results. So if you look at that search string, right, you can see here the term mid-century modern, right? And the top result in the hybrid search results is mid-century modern. So it's a keyword match, right? So that's what you get when you do a hybrid search. When you combine full text search results with vector, you get kind of the relevance of the exact match of the keywords kind of brings the results up, right? So if that's what you want, the hybrid search is really good for you. And there are use cases where keyword matches are important, right? But in our scenario, I think more important is kind of a style and semantic matching, right? So let's improve on that. So to do it better, we are actually going to enable semantic re-ranking. And to do that, it's just another parameter on our search function. We'll say, hey, do re-ranking equals true, right? So let's do that. And semantic re-ranking will significantly improve kind of relevance of our results from the semantic point of view, right? So it uses this cohere semantic ranker model behind the scenes. And now, as you can see, the results are slightly different. The coffee tables here are kind of found more relevant to this query result, probably because our search string includes wood tones and dark vibes, right? So coffee table has kind of a more surface. I don't know. So that's how easily you can enable semantic re-ranking and improve accuracy of your query results, right? But that simplified function may seem like kind of opaque or like a black box, right? So how do we understand what's happening inside of this search function? So this is another feature that we can demonstrate. So we have here visualize query plan button. And that allows us to look inside of any queries that we are running, right? So I'll do that and create a visualization of these queries that we just run. And here we go. So let's zoom out a little bit. So this is pretty large query, right? But we can safely ignore this part of the query. This is just our joins where we format the output, right? So let's ignore that part. So this second part is actually our search function. And if you zoom in on it, we can see exactly the structure of what is going on behind the scenes, right? So let's further zoom in. So we can see that the query starts with two steps. So first it does a full text search, and it performs vector search in parallel, right? So that gives you two lists of items with different priorities. And then what we do as a hybrid search, we do reciprocal rank fusion. So that's basically a formula here. Very simple, actually, mathematical formula that kind of averages out the two results, right? So it allows you to take two ranked results and merge them together, averaging out the rankings. And after that, because we enabled the semantic re-ranking, right, we perform a call into a semantic re-ranking function to take these 30 candidates and reorder them now in the order of semantic relevance, right? And finally, that allows us to take out of the 30, we take the top 10 that are the best matches, right? And because we requested top 10 results, we return the top 10 results. So that's kind of the interesting way how our Postgres tooling that kind of has this query plans allows us to understand what's going on behind the scenes. So that's how this intelligent semantic re-ranking search was done. And we are doing good on time. So the last step I wanted to show is a very powerful step, knowledge graphs, right? So the heart of the intelligence of this agent, of this app, is being able to match styles, right? So look at the photo and then determine what is the stylistic kind of matching between this piece of furniture. So what we did, we created a knowledge graph of styles for this product catalog. And in the interest of time, I'll skip that step, but you're welcome to look at the repo. It has yet another AI pipeline and SQL scripts that actually builds a knowledge graph. And it stores this knowledge graph, again, in Postgres in a real graph manner. So we use Apache AGE extension for Postgres, which basically brings a graph capability, graph database capabilities on top of your relational Postgres SQL. So that allows you to run this Cypher query. So if you look at these queries, so this is how Cypher query looks like. So it has a bunch of matches. It allows you to traverse relationship in your graph, right? So very cool. But let's run it and see the results. So if we run this graph query, what we see is a visualization of the graph, because that's what we have in our tooling as well. And if we zoom in a little bit more, then then in the middle of this graph, you can see a style, mid-century modern style, right? And that style connects coffee tables. So here is this one coffee table, right? So that's a category, coffee table. So it connects this coffee table to various other items, right? So it connects to chairs that have similar style. And it connects this coffee table to bookcases, right, of the similar mid-century modern style. So that's kind of the basic idea of this style graph, right? It allows you to connect furniture with styles together. But it's kind of simple, right? What happens if there is not enough furniture of particular style, right, that matches your own? Well, styles are actually similar to each other. And that knowledge we expressed in the knowledge graph as well. So we can actually go better, do better than just showing connecting styles, connecting furniture based on styles. We can also introduce this relationship similar to between two styles, right? So our mid-century modern style is similar to Bohemian style, right? And that knowledge expressed in our knowledge graph allows us to, again, traverse from this chair and connect it to a similar area rugs, and basically fulfill our room, desired room, with a much broader variety of furniture options, right? So that's kind of how knowledge graphs work. They're a very powerful tool, applicable to almost any domain, right? And they frequently kind of encapsulate this domain knowledge that you have, right? So they're very powerful for enhancing intelligence and quality of operation of your agents. Cool, so that's all I had. To conclude, let's go back to our app and see what was actually, what it did, right? What we did. So if you look at the agent details, in this demo, we were able to prepare our data, right, for agent consumption, for AI consumption, using AI pipelines. We were able to perform powerful hybrid search with all kinds of sophisticated accuracy options. And we were able to use semantic re-ranking, right, to pick the best rooms related to our room. And of course, we find related products using knowledge graphs, right? So all of that functionality we were able to achieve just using built-in Horizon DB AI features. So no external services, no complexity, right? And very few lines of SQL if you prefer that. If you're interested in trying it out yourself, here's the repo with all of the source code and sample queries, right? It has only 60 rows as a sample data set. But it's enough to kind of illustrate how simple actually behind the scenes this app is. And that's it.